ODS is the biggest data science-like community in the world, so it's a very interesting object for research and observation because it contains more than 1 million messages, 5,000 users, and 100 channels with a lot of very interesting and useful information. So we collect the following data by users, by channels, by trends, by time response, and etc. Here's some graph visualization. This graph represents connection between channel in 2016. It's a very interesting graph because, as you can see, there's a very strong connection between two dots, boats and random flood. It means a very big, huge amount of users who want to just chat with some funny stories. Here's the next year, 2017. It's very interesting graph because green cluster represent guys who has GPU, and while they took participation in different competitions, they discussed some problem in channel like cable plug, satellite imaging, and etc. But when competition is end, they mining bitcoins and use for discussion channel blockchain and in general hardware. So it's another graph represents the most active users in trend, most active users in random food channel. Probably this guy you probably know. And most active users in career channel. This graph is very interesting too because, as you can see, blue cluster represent people who friends in real life. So graph understands this connection. So and our next task.
Yeah, we have made several nice fancy plots with different instruments. So the first plot is about machine learning open course channel, and you can see that the number of users increase in time, and we have determined the reason. So we have created several plots to determine the reason, and you can see it here. And we also Google Trends, and the graph also displays the messages in the blockchain channel. So you can see that there is some dependence between these two. There is also the graph of dependence of the number of users in the blockchain channel and the price of the Bitcoin, and you can see that we are on the plateau at the moment. And this is also displayed on this heat map. You can see that as of now the discussion is not that sharp as before. We have also made several heat maps on the main channels and discovered the main events happening there. You can see this slide for the career channel and the discussion per day, and these are the main two events for this channel. We also have the heat map for deep learning channel and the corresponding events here, and also the theory and practice channel with the main two events for this channel as well, and of course the random flood channel and the events for it in the nearest recent future.
About analysis of users' activity, we try to detect some kind of users. It's curious users who ask for help, expert users who have very good answers in threads, and trolls. All you know what is promotion. So it's a bar plot with some distribution by 2 years. So you can see that some guys wrote in 2016, and some guys on the joined channel in 2017, and it's a top 20, I guess, most curious users. Yeah, it's here. We have a very smart guy over here. So, about top expert users by channels, we distinguished the experts by specific reactions, so they indicated the experts. We also have some distribution by most popular channels. You can see this plot. And the same with top troll users by channels. Also, these reactions indicate that it is troll. And yeah. So, and we find out that some users are both trolls and experts. And guess what?
So the next problem we decided to solve is estimating the response time in different threads. So we had more than 12,000 threads in 47 channels within time period from 2016 to 2017. Formally speaking, we had a regression problem with a lot of different features. The best one was whether there was any users mentioned in the text, the length of the main message, and also the day and hour of the main message. So we used different approaches, and such as lasso regression, XGBoost, and light GBM regression. The best one was light GBM regression, but it is not as good as we want it to be. So what are the future improvements? Generally speaking, it could be using more sophisticated features and getting more data. So that's it. That is.
Yeah, okay, so I'll go to the other problem. The thing is, as you may know or may not know, Vitaly is the administrator of the ODS channel. And what he told us is that there is an issue with many channels, not ODS specifically, but that many people who are being banned as bots, they're coming back under new nicknames, and it's very difficult to distinguish them sometimes because, well, they have changed the nickname. So is there any way to predict whether a person has already been banned? Well, actually yes. So we can classify users by their by what they're texting. So we had analyzed top 100 users in 12 channels, and we have used 120,000 messages. And well, we didn't have much time for this, but we weren't fine-tuning it a lot. But what we have tried is logistic regression with convectorizer and one versus rest classifier, and linear S support vector classifier. Well, and as you can see, well, logistic regression here was better, even better than LSTM, which we have then used. Okay, but now more interesting topic specifically for me. So channels classification. There are many people joining ODS Slack every day, like tens, hundreds of those. And there are more than 100 channels in ODS chat. So what can you do if you're a newbie and you don't know which channel to text to? Well, what you would do is you would just enter the message, what if it could show you which channel to send it to? Well, we have tried to do that. We have analyzed 12 channels using the same amount of messages as for user classification. We have tried regression models, like logistic regression, linear, support classification, also CNN, LSTM. We also have tried one more algorithm, which is obviously the favorite algorithm of our team lead, which was XGBoost, but it performed worse. And though he asked us not to talk about this, we have also used it.
How is it possible?
So, but in the end, what we thought, okay, if they're performing not as good as they can, why don't we make an ensemble? So we made an ensemble out of all these three, and well, it performed better, as you can see. So it was 58%. And yeah, so here you can see how it actually classifies the message. And yeah, I'll go to the very end. I think there is one better one, so this one. Because as you can see, art is specifically mentioned here, but it actually distinguishes that it is specific to Python channel. Okay, so that was it. And I would like to thank to our team and to our team lead, who has done a great job with us. Thank you all. And thank you for your attention.
Thank you so much.
I'm sorry. And all the materials you can find by the link. It is open. Try it.
Okay, guys. Thank you.